Hello everyone, I am Kalyani Shashikant Chaudhary, Faculty of Civil Engineering Department from Vishwa Bharati Academy's College of Engineering, Ahilyanagar. Today is the sixth lecture for the survey subject of Unit 1, that is Compass and Leveling. In this lecture, we will study about leveling. And the content of this lecture is as follows, like introduction of leveling, important terms in leveling, types of benchmark and types of levels, etc. First of all, we will understand what is leveling and what is the need of it. For what purpose the leveling is used, we will understand here. Leveling is used for the measurement in vertical direction, or you can say that leveling is used to find the elevation difference of various points on the surface of the earth. Now, what is the elevation of a point? Elevation of a point is its vertical distance above or below a reference level called datum. Datum is the mean sea level. Now, what are the objectives of leveling? Number one, to find the elevation of points with respect to the given datum. Number two, to find the position of a point at a given elevation with respect to the datum. Number three, to find the elevation difference between the to find the difference between the elevation. Now, we will understand each and every term of leveling. Before going to the definition of the term, we will understand this diagram. Okay, we all know that the shape of the earth is oblate spheroid. Okay, now consider this layer as the shape of the earth. Okay, this is the oblate spheroidal shape of the earth, and this surface there is a sea. Okay, and this is the water in it. Okay, so and this is the topmost layer of this water, and this water uh, took the shape of this surface, that is the shape of the earth. Okay, means this water is as per the shape of the earth, and this topmost layer of the sea, we consider it as a mean sea level. Okay, now we will see the definition of each and every term, and according to that I will try to show you it in this diagram. Okay, first of all, uh, keep this in mind that shape of the earth is oblate spheroid. Okay, number one, now the level surface. Level surface is the surface which is parallel to the mean spheroid of the earth. Now the level line, a line laying on the level surface, it is the level line and it is normal to the plumb line. Now look at here. This is the means this is the actual shape of the earth, that is oblate spheroid. This is the mean sea level, and this mean sea level took the shape of this earth. Okay, so this this shape is also parallel to the mean spheroidal shape of the earth. So what is level surface? Level surface is the surface which is parallel to the main spheroid of the earth. That is, any surface parallel to this surface is called as level surface. So there are infinite number of the level surface, and any line which is drawn on this level surface, that is the surface which is parallel to the mean spheroid of the earth, is called as the level line. means the surface parallel to the main spheroid of the earth is level surface, and any line drawn into it is called level line. Okay. Now the horizontal surface, the, the surface which is tangential to the level surface is called as horizontal surface, and the horizontal line, any line laying on the horizontal surface is called horizontal line. Now look at here. This is the mean spheroid of the actual shape of the earth, that is mean spheroid, and this is the surface. Okay, this is the horizontal surface. This surface is tangential tangential to the level surface, or you can say mean spheroid of the earth, and any line laying on the horizontal surface is called as horizontal line. Now, the reduced level, or you can say elevation. It is the vertical distance above, it is the vertical distance of a point above or below the datum. It may have positive or negative value according to its position above or below the datum. Okay. Now, benchmark. It is the fixed reference point of known elevation. The leveling work is always started from the first reading on the benchmark. Now, what are the types of benchmark? Number one, Great Trigonometric Survey benchmark, permanent benchmark, temporary benchmark, and arbitrary benchmark. Now, we will understand the importance or the information of each and every benchmark. Number one is Great Trigonometric Survey benchmark. It comes under the control of Survey of India. In this survey, the actual shape of the earth is considered and it is very accurate. Okay. Now, the permanent benchmark. It is established with reference to the Great Trigonometric Survey benchmark. The reduced level of this benchmark is usually marked on the top of the permanent object. From this, you can understand that Great Trigonometric Survey benchmark are the number one and very accurate benchmark. Okay. As per that, or according, or with the help of that, we can mark the permanent benchmark in each and every state. Okay. And this permanent benchmark are usually marked on the top of the permanent object. That is, any permanent building may be there, or any permanent object they find, and there they mark the permanent benchmark. Now, the temporary benchmark. When the survey work continues for a number of days, then any object is chosen on which that day work is stopped and can be started is called as temporary benchmark. Now, understand. Like, if you want to do the survey of a road or anything, ठीक anything, okay, then the survey work continues for a number of days, and for that number of days we have to finish the work at the end of that day. So to stop that work, we take a reading on any object, and the work is stopped. That reading is nothing but the temporary benchmark. From that reading, we can start, or we have to start the next day's work. Now, the arbitrary benchmark. For small and less important work, any convenient point is chosen to take as a benchmark, and that benchmark is the arbitrary benchmark. For small and less important work, the arbitrary benchmark we will used. Now, what is level? An instrument which is used for observing staff reading on leveling staff kept over different points after creating a line of sight is called as level. An instrument which is used for observing staff reading on leveling staff kept over different points after creating the line of sight is called a level. The difference in elevation between 2 points then worked out. Now the types of level: dumpy level, auto level, Y level, etc. Now the instruments used in leveling, that is level, tripod stand, and leveling staff. Parts of the dumpy level. Okay. Number one, leveling head. Number two, focusing screw. Number three, telescope. Number four, eyepiece. Number five, objective. Number six, diaphragm. And number seven, level tube. Okay. Now, the important terms in leveling work. Number one, axis of the telescope. It is the line joining the optical center of the eyepiece and the object glass. Number two, line of collimation. It is the line joining the intersection of the crosshairs of the diaphragm to the optical center of the object glass and its continuation. Number three, line of sight. It is the line joining the intersection of the crosshairs of the diaphragm to the optical center of the object glass. Backside reading. It is the first reading of the leveling. It is taken on known elevation. Now, the foresight reading. It is the last reading of the leveling and it is taken on the unknown elevation. Intermediate sight reading. All the readings in between backside and foresight are the intermediate sight reading. Now, the change point. It is the point on which foresight and backside readings are taken. Change point is needed when we have to shift the instrument. Parallax. It is occurred due to the imperfect focusing. It is present when the image formed by the objective lens does not lie on the plane of crosshairs. This is the error of leveling. Now, the types of leveling. There are many types of leveling. We will understand it one by one. Number one is simple leveling. Number two is differential leveling. It is also called as compound leveling and continuous leveling. Number three, profile leveling. It is also known as longitudinal leveling. Number four, cross-section leveling. Number five, fly leveling. Number six, check leveling. Number seven, reciprocal leveling. Number eight, trigonometric leveling. These are the types of leveling. Now, we will understand the uses or information for every leveling. Okay, first leveling is simple leveling. Here you can see the diagram of it. From that you can understand what is simple leveling. Okay, this is used to find the difference in elevation of the points which are visible from the single or same instrument station. Means in simple leveling, we can easily find out the difference in elevation of 2 points which are visible directly without changing the position of the instrument. So there is no need of change point in simple leveling. Now the differential leveling. Look at the diagram. Okay. When the elevation difference between 2 points is much more, then the differential leveling is used. It is used when there are some obstructions between the points such as hills, trees, etc. In this leveling, more instrument setup is required. Now, the profile or longitudinal leveling. To determine the elevation of points at measured intervals along a fixed line, this profile or longitudinal leveling is used. For example, center line for railway, highway, sewer, etc. Foresight, backsight, and intermediate sight readings are taken here. Now, the cross section leveling. Leveling in this, the leveling is done perpendicular to the center line. It is used for the lateral outline of the ground surface. Fly leveling. It is used when fast leveling work is required. Check leveling. It is used to check the accuracy of field leveling work. Reciprocal leveling. Reciprocal leveling is used when there is large obstruction between 2 points, for example, river, hill, valley, etc. Now, the trigonometric leveling. The elevation of points are measured from the observed vertical angles and the horizontal distances measured on the ground. This leveling is known as the trigonometric leveling. Now, the height of instrument method or collimation method. Height of the instrument. The reduced level of the line of collimation is known as the height of instrument. We can calculate the height of instrument by using the formula reduced level of benchmark plus the backsight reading. Now, the formula for reduced level of any point is equals to height of instrument minus foresight reading, or reduced level of any point is equals to height of instrument minus intermediate sight reading. Rise and fall method. Difference of level between two consecutive points is found by comparing the staff readings on the 2 points of same setting of the instrument. Now, in this slide, we will understand in short and simple way the difference between the height of instrument method and the rise and fall method. Height of instrument method is simple, less tedious, less accurate, less calculation is required in it, and it is a fast method. Now, the rise and fall method is difficult as compared to the height of instrument method. It is more tedious, more accurate, and more calculations are required in it, and it is also a slow method. In height of instrument method, the error in calculation is not carried forward, and in rise and fall method, the error in calculation is carried forward. Height of instrument method is used for profile leveling and to prepare contour map, and rise and fall method is used for fly leveling and check leveling. In height of instrument method, there are two checks which are required. Number one, summation of backside reading minus summation of foresight reading. And number two, last RL minus first RL. That is last reduced level minus first reduced level. In rise and fall method, three checks are required. Number one, summation of backside minus summation of foresight. Number two, last reduced level minus first reduced level. Number three, summation of rise minus summation of fall. Okay. These are the checks of the rise and fall method. Read each and every term again. Thank you.